Hi. Today we're looking at greenhouse gases. Actually, we're looking at greenhouse gases, the greenhouse effect, and climate change. Probably should have modified the title, but that's where we're going. So by the end of today's lesson, you're going to be able to explain how human activity can change the proportion of greenhouse gases in the atmosphere, and then what are the consequences of that happening. To start, let's just go back to, we talked about it last lesson, photosynthesis. Can you write a word equation for photosynthesis? Something plus something, arrow, something else. Can you write the symbol equation for photosynthesis? And then can you write the list the gases in the atmosphere presently and write them in the order of the highest to lowest amount? Okay, so pause the video, answer the questions, and unpause when you're done. Okay, so let's just check I've got the pen setting on. Pen. The word equation for photosynthesis is carbon dioxide plus water. So I do need water. Arrow becomes a glucose plus oxygen. You could add here light if you would like to. What is the symbol equation for photosynthesis? So we need CO2 plus H2O, arrow, C6H12O6 plus O2. If you wanted to balance it, excuse me, you should add a 6, and a 6. Excuse me, allergic to photosynthesis. List the gases in the atmosphere in order of amount. We have nitrogen, and then oxygen, and then argon, and then CO2, and then other gases. Okay, so there's a lot of information again today. Today you're just going to have to take it in, and there'll be some questions peppered in the middle. How is the Earth warmed? The Earth's atmosphere acts like a glass in a greenhouse and is needed to keep the planet warm enough for life to exist. Sunlight passes through the Earth's atmosphere, and the Earth gives out infrared radiation. Certain gases trap some of the radiation in the atmosphere, which keeps the Earth warm. This is called the greenhouse effect. Having some greenhouse gases is a good thing. If it wasn't for these gases, the Earth would be too cold to live on. So the greenhouse effect is a good thing. It's an important thing. It's an essential thing for life on this planet. So let's look at it in more detail. So the Earth is warmed by the sun. So here we have the sun. Sun, stage 1. Radiation from the sun travels through space and comes to Earth. Different amounts of radiation. We'll look in another lesson. We've got radio waves, microwaves, infrared, visible, ultraviolet, X-rays, gamma rays. They all leave the sun, and they all come all out in a circle, in a sphere, and they come towards Earth. Some of it, point 2, some is reflected by the atmosphere and things in the atmosphere. Some is reflected by the Earth's magnetic field. So some just bounces away, never makes it through. That's fortunate. Some of that stuff is dangerous, and if it did come through, it would kill us. So some of it is just reflected away. Some comes into Earth and is absorbed. So the light comes in and it hits the Earth, and that causes the Earth to warm up. Now, when the Earth is warm things give off infrared radiation. That's 3, 4. Warm things give off infrared radiation. It's a type of radiation that's associated with heat, thermal radiation, infrared radiation. And this infrared radiation leaves the Earth and travels up to the atmosphere. And some of it will escape, but quite a lot of it is reflected back down by the greenhouse gases in the atmosphere. This warms the Earth up. So, for example, The greenhouse effect is good. Excuse me. It's like a duvet on your bed. If you lay on your bed in the daytime, it's fine. The sun comes in, it keeps you warm. But at night time, the temperature drops. And if you don't have your duvet on you, the heat from your body will escape and you'll become too cold. The greenhouse effect is a similar thing. I think the example is like a car. So if you've ever got in a car on a really, really, really hot day, what happens is the sunlight comes through the car the windscreen, and it strikes the dashboard and the chairs and all the things inside. And normally the bits inside your car are quite dark, and they absorb all of that light energy, and they get hot. And then what happens is the infrared radiation, the things that are hot give off this infrared radiation, but the glass and the rest of the car traps that radiation inside, and the radiation that's inside can't get out. So if you open the door of a car on a hot day, it smells and it's really hot. The heat, the hot air, because it has been trapped inside by this. In this case, it's the car. The greenhouse effect traps the heat inside. We can look at it again in the form of an animation. Radiation from the sun in the form of light waves enters the atmosphere and warms the earth. They've ignored some of this stuff. So when you warm, then the earth gives off infrared radiation. So this light coming in and this radiation are not necessarily the same types of radiation, but the earth absorbs one, gives off another. Some of this travels through space. Some of this is absorbed by the greenhouse gases and is then reflected back to Earth. This causes the Earth's temperature to rise. Increased levels of greenhouse gases in the atmosphere means more heat is trapped. This leads to a greater increase in the Earth's temperature. So I'm going to leave this PowerPoint for you on the VLE, and you can do this. You can rearrange these things to try and work out, can you get the correct order for the greenhouse effect? So I'd advise you to do this yourself. But first of all, let's have a look at some things. Complete the paragraph by using about the greenhouse effect by inserting the correct words from those listed. Each word can only be used once. Greenhouse gases allow something wavelength rays, for example, something rays to pass through. However, the surface of the Earth cools down by emitting wavelength rays like rays, it's quite difficult to read, which are something by the greenhouse gases. This radiation causes in the molecules of greenhouse gases to vibrate, which causes the temperature to. Because you can only use each one once, there are some options that are easier than others. So, do the ones you can do, leave the other parts for you to work out. And this, you don't have to write the whole thing down. You can just write the numbers. That's why I numbered it, because I'm nice like that. What happens when fossil fuels are burned? Here we have examples of fossil fuels: coal, oil, and gas. Fossil fuels are burned to generate heat. This combustion reaction creates carbon dioxide and water as a waste product. Fossil fuels plus oxygen goes to carbon dioxide and water. There should be an arrow there. Something's gone wrong. Arrow. The greater use of fossil fuels is thought to be the main source of increase of atmospheric carbon dioxide. Burning wood releases carbon dioxide into the atmosphere. Deforestation reduces the amount of photosynthesis taking place and so increases the carbon dioxide levels. Rice farming and cattle farming produce the greenhouse gas methane. This gas is 7.5 times more effective as a greenhouse gas than carbon dioxide, but it is currently in the atmosphere at much lower levels. Atmospheric carbon dioxide levels are measured around the world to detect global trends in greenhouse gases. The standard measure for this is parts per million. In 2005, levels were around 370 parts per million. This means for every million parts of air, 370 parts of carbon dioxide. In 2020, levels are 415 parts per million. That is a lot. That is a big increase. Mauna Loa Observatory in Hawaii is located at an altitude of 4,170 meters. I don't know if you've ever looked at a map and seen where Hawaii is. Hawaii is right in the middle of the ocean, quite literally slap bang in the middle. Like, couldn't be further away from many other places. And so, if you're on Hawaii, the pollution levels that you're measuring, the carbon dioxide levels you're measuring, are going to be like a good representation of kind of the average over the planet. Because if you measure it in, say, a city that has lots of factories, then you're going to expect these very high levels. But if you measure it in quite literally the middle of the ocean, and not just in the middle of the ocean, but nearly 4,000 meters above the ocean, all those carbon dioxide from those factories and cars and planes will have spread out. And so, as a consequence, what you're measuring there will be a good example of the average for the whole planet. So there'll probably be places where it's even higher. But on average, at the moment, 415 parts per million. What is the trend of atmospheric levels of carbon dioxide? Well, if we look at this from going back to 1960 to up to 2000 and something, we can see that over time, the levels of carbon dioxide have risen. Just over 300 to just below 400. Now we're above 400. Just below 300 to over 400. So it's a constant rise. But how do we know more than that? How do we know what happened to carbon dioxide before we were able to record it in the 1960s and 70s? Well, if you go to places like the Antarctic, you'll you'll be aware that it's full of ice. It is ice. And some of that ice has been there for millions of years. Now, what these people have done is they have drilled down into the ice and just taken a long tube of ice out. Now, these ice cores, by studying them, help us understand inside those ice cores are little bubbles of air. They were the atmosphere then. And they can analyze the air in those bubbles, and they can see what the carbon dioxide levels were going way back for thousands and thousands of years. They call this a proxy record. They indicate climate measures that have not been recorded using instruments. How has it changed? If we go back thousands of years, nearly 500,000 years, we can see it has changed a lot. So, changing levels of carbon dioxide are not bad. It's a natural process. It goes up, it goes down. The problem is, lately, the change has become dramatic. So, you saw in that previous graph, levels going up and down and up and down and up and down and up. The problem is that since the Industrial Revolution time, what's happened is the levels of carbon dioxide have gone up and up and up. They've gone to levels that have never really been recorded before anywhere in the history of the planet. So, yes, they go up and down, but now they've gone up at a crazy level. And if you note the two things, so this graph is quite detailed, but you've got this line here is the average temperature difference, and these are the levels of carbon dioxide. And we can see that, hopefully you can see that this kind of colourful, the blue and the red, show that as time has moved on, the carbon dioxide concentration has gone up and up and up and up. So it's quite high. And you can see that as the carbon dioxide levels have gone up, the temperature change has kind of coincided with it. It hasn't changed, hasn't fluctuated as much, but we can see that the average temperature change is increasing along with the increasing rate of amount of carbon dioxide in the atmosphere. You increase the carbon dioxide, you appear to increase the temperature. These are the facts. These are just the direct observations of what we can see. If we have more carbon dioxide, you have more temperature. In fact, the last 20 years, which have had the most carbon dioxide in, have been the hottest 20 years on average. Time for some questions, though. State 3 human sources of carbon dioxide gas, excluding respiration. Can you think of a human source for methane gas? And what's the difference between the greenhouse effect and global warming? So answer the questions. Write down 1 to 3. Just write down the answers. Pause and unpause when you're done. Okay. What is climate? Climate is not the same as weather. What is the difference? Weather is the state of the atmosphere at a given place, given time and place. It is measured in terms of factors such as temperature, rainfall, humidity, and cloudiness. Climate is the average weather for a region over a long period of time, usually 30 years. One way to remember the difference is climate is what you expect, weather is what you get. Weather can change several times a day. The climate normally takes a long time to change. What would happen if the climate would change quickly? And let's look at some impacts of this climate change, because the climate is changing. Nature. Climate change could cause habitats to change faster than animals can adapt. Polar bears are one species that could be at risk from extinction. Weather. In 2005, New Orleans was hit by Hurricane Katrina, one of the most powerful hurricanes ever. Rising sea temperatures could mean hurricanes like this could happen more often and more extreme. In the European heatwave of 2003, over 20,000 people died. Although a milder climate might be pleasant, heatwaves can be a real problem if temperature increases. Warmer weather has already increased the length of the growing season in Europe. However, tropical areas could suffer far more droughts and famines. Hotter temperatures could encourage the spread of diseases like malaria. Mosquitoes, the insects that carry malaria, will be able to travel further north as it becomes warmer. A change in water temperature by 1 or 2 degrees could be enough to destroy coral reef ecosystems. Australia's Great Barrier Reef could lose 95% of its species. Decreasing snowfalls have begun to affect skiing and snowboarding. Some resorts have had less snow cover on the slopes and have needed to close for the summer sooner. So, the climate. List 3 possible consequences of global climate change. Describe why they're difficult to predict. Suggest 2 problems that representatives of countries face when reaching international agreements. Ooh, tricky. Suggest and explain the relationship between a nation's wealth and its emissions of carbon dioxide. Can you explain your reasoning? And state 2 ways in which greenhouse gases can be reduced. Quite high-level questions, but you're smart. So, answer the questions, and don't forget to send your work in. I'm sure you can do it. I believe in you. Love you. Bye.